here on this bench. So please, Mr. PEERANI, and thank you for joining the workshop.
Thank you, Madam the Chairman. So my name is Paolo PEERANI, and I'm head of a nuclear decommissioning unit at the Joint Research Center of the European Commission. I'm going to start with setting a little bit a picture of the framework of a nuclear decommissioning in Europe, and then I will briefly talk about what the Commission can do to contribute to the nuclear decommissioning process. So some figures that some have already been told in the introduction. Currently, there are roughly a little bit more than 200 nuclear power plants in Europe, 90 of which have already been shut down. Some have even already started the dismantling process. But, as evidenced before, the ones who are in operation are quite old. The average age of the fleet in Europe is roughly 31 years. And knowing that typically the lifetime of a reactor is between 30 and 40 years, that tells us that in a short future, a lot of them will reach the end of life. So we can easily expect that 50 more nuclear power plants will be finally stopped by 2025, bringing, let's say, the overall volume of nuclear power plant to be decommissioned to some 140 or so. What does it mean in terms of costs? The decommissioning costs are affected by huge uncertainties. The illustrative program of a Commission on nuclear has published last year a report bringing some figures coming from the experience in the different member states. And for instance, we see that there is a huge variation in the estimation cost of the power plant in the member states. For instance, the decommissioning cost, doesn't matter if we speak in terms of unit or in terms of power, so per gigawatt hour, for some member states are around 300 millions, from some range up to more than 1 billion, nearly 1.5 billion. So even taking a sort of average value, we end up with the estimated cost for the decommissioning of around 120 billions. But still, this figure, as I said, is affected by a large uncertainty. Moreover, the experience tells us that the estimation on the decommissioning cost have tendency grown in the last year. So the estimation of a few years ago were lower. Now they are like that. We can easily expect that in a few years the estimation will be higher. And this is only part of the story, because to the pure dismantling cost we have to add the waste management cost, which are affected by even higher uncertainties. So the waste management cost at the current estimation nearly will double order of magnitude the dismantling cost. So we expect something in the range of 260 or so billion for the final cost of dismantling and waste disposal. Why there is such a big uncertainty, especially on the waste disposal? You have here the situation of the current status of final repositories for spent fuel and rad waste. You can see with triangles there are the final repositories for in the deep geological repositories, so for spent fuel and high-level waste. The rectangles are the surface repository for low-level rad waste. And the one in operation are the green one. So you can see a lot of countries have, some have neither one or the other, some have only one, but basically there are no countries that are, or very little countries that are already equipped for accepting the rad waste. Lacking of that, clearly any estimation of cost is pure speculation. So one action that is necessary from the member state is to go on with a solution for waste management. So what the Commission can do? I introduced just briefly my institution. The Joint Research Center is a Directorate General of a European Commission, but it's a special Directorate General because it's a research center. It's let's call the science and technical branch of the Commission that gives support to the policy DGs in developing their policies. There are roughly 3,000 scientists that work in 5 sites on the member states, plus the headquarters in Brussels. And most of them, indeed 4 sites, are engaged in nuclear research. Ispra in Italy, where I come from. Then we have large radiochemical installations, hot cell in Karlsruhe in Germany. We have a reactor, high flux reactor, which is producing the large majority of radioisotope for medical application in Europe, in Petten in the Netherlands. And not far from here in Gel, we have a setup of accelerators. So having nuclear installations, some of them are already reached the end of life. So also the Commission has started its own decommissioning waste management program in 1999 that is taking care of all the historical liabilities for the already shut down facility, and in future the liabilities for the one that are still operational today, but will be closed down one day in time. And in particular, the Ispra site, we have plenty of nice toys to take care. We have 2 reactors already shut down, research reactor. We have radiochemistry labs, cyclotron, waste management facility, whatever you would like to have. So we are also a nuclear operator that has a nuclear decommissioning program. And what does it mean? What does it bring as added value? The possibility to put together research and operational experience. In 2012, a workshop organized by the European Parliament gave a mandate to the European Commission to JRC in particular to increase its support and the research and development program on decommissioning. And this can be done in parallel with the execution of a decommissioning program. And this brings us a lot of opportunities. That means that researchers work together with operational people who does real decommissioning work. And then this creates synergies, for instance, transfer of user needs, feedback on the researchers, and possibilities for the researchers to apply and test their prototype on field on a real scale decommissioning program. Is there need to do research? This is a question. Many people, it's quite debated. Some people tell us that there is no need of research because everything is available. Somebody uses the contrary fact to explain why the large cost in decommissioning. Large cost in decommissioning because any kind of decommissioning project is a sort of first of a kind. It's a new thing. There is no standard tools, standard procedures. That's why everything has to be started from scratch. So where is the truth? Truth, as usual, is somehow in the middle. Yes, we have the tools today. The current technology allow us to do decommission a nuclear power plant. Nevertheless, the situation is far from being optimal. There is always possibility to improve and to have better tools. These are a sort of overview of where are the current technological gaps. First of all, metrology, measurement. We have to characterize waste, we have to clear waste. So we need a very accurate and powerful measurement methods. Decontamination, to reducing the amount of waste, to clean them up in order to release a large mass of the waste produced as conventional and not radioactive so decontaminating the water of the ponds, decontaminating metal components and concrete. Safety of workers. They have to work in a highly radioactive environment, so replacing the presence of man through remote control and automated operation will reduce the exposure of workers. Site remediation. If we want to go to greenfield, we need tools in order to map and verify the status of the soil around the installation, and eventually to decontaminate the soil. And finally, all the problematics connected with the repositories. Long-term behavior of the radioactive material, compatibility of material with the matrices for let's say, for containing and the engineering barrier in order to stop the possibility that this radioactive enter into contact with the biosphere, the migration of the contaminants in the biosphere to each man. So all sort of problematic that needs still research and development. And I will not repeat everything. JRC is working in most of these problematics, and non-destructive and destructive analysis methods, behavior of spent fuel, remediation of sites, accidental, for instance, post-Fukushima, and so on. So a lot of research is still ongoing and will be needed in the future years in order to get better tools and better methodology for decommissioning. But this is not still enough. To carry over an important decommissioning program, you need, of course, technology, you need tools, you need methodologies, but you need resources. Financial resources I will not touch. There will be a dedicated session this afternoon, but also human resources. So you need a person with the appropriate capabilities and skill to perform a work that is new. Let's call it, it's new in the panorama. So JRC is also working in the education and training for decommissioning through an initiative that has been launched last December, ELINDER, European Learning Initiative for Nuclear Decommissioning and Environmental Remediation, that put together many stakeholders, research center, universities, and nuclear operators to set up a comprehensive scheme for vocational training of professionals working in the nuclear decommissioning. And this will come in the next year to set up a pool of experts and professionals that could help and work in the decommissioning field. Thank you. I hope having respected the time frame that you have set up.
Since we also respected the frame for the year 2020, I used my right as the chair of the session and asked you, so would you say from the perspective of the Joint Research Center the task of decommissioning, because we are now learning why to do it, came as a surprise to the nuclear community?
Of course, it's not a surprise. There has been working on that since many years. The problem is that nuclear is a shortly evolving world. It's not like, let's say, informatics, where after 3 years you have totally new tools and totally new. The nuclear works historically on a much longer evolution time, because it requires research with peculiar infrastructures, a lot of investment.
Thank you. So next speaker, we have